Hello everybody and welcome to my little YouTube corner. My name is Auticus, and what I wanted to do today is I wanted to post a little game development video showing how I managed to improve on a jumping tutorial that I had found online. So I have a link down in my description of this video. This is to Sebastian Graves' a YouTube tutorial series on working in Unity with a Dark Souls-like game. It's an amazing, tremendous, awesome series. I recommend this to anybody who's got at least some familiarity with C#, the development language, and some Unity experience, because it really shows you another way to approach how you would handle a game like this. Just a little bit of background on me. I got into the game development world in 1993, so it's been about 30 years since I've been a professional software developer. I've been using Unity for 9 years, but most of my work has been involving tactical or strategy games. So I have a project going that deals with something of the Dark Souls nature, and I went out to look for a tutorial on how to do that. And there are some out there, but Sebastian's came right up, and it was perfect. But so I want to show you a little bit of an alternate way of how I did this. This is in direct response to episode 19, which is what I've linked. And what it shows when I finished the tutorial, the jumping animations worked, but they were kind of anemic. And I'm going to show you that here on screen here in a moment, what that means. So go ahead and run this. And I'm going to look at what looks like a hot reload. Oh, Unity crashed on me. You know why Unity crashed on me? Because I'm in the middle of a demo. It hasn't crashed all day, and today it crashed on camera. Sweet. Not to worry, we just restart it, and hopefully that'll address the issue. Anyhow, while it's doing that, this is gonna handle how I made jumping work a little bit better. It just feels a lot better now for me. So, and it was actually, the fix was not that bad, but getting to that point where you know it's not that bad was usually what takes the work. So again, let me go ahead and try to run this. See if we don't crash. Okay, we don't crash. Cool. So a little bit of a deviation. I have developed this system very much differently than how Sebastian has done his work. I use his as kind of like a framework, and then I move into how I would want to do it. So I'm going to show you those differences in a minute, because you're going to need to see that. But one of the differences, I can jump in place. So you can see here, jumping in place. It doesn't jump very high, but then when we run and we jump, it's the same thing. So this is what some people have been commenting on, like the jumping is just not exciting. So let's look at how I deviated from this in a little bit. Number one, my player rig is actually, it's the mesh itself, and then I have Cinemachine. So I didn't code my own camera. I like Cinemachine quite a bit. I just use theirs, and it works great. So this is a big difference, because all of my scripts are actually on this knight object, which is my player. And that also includes my rigid body and my capsule collider, which you can see here. So my capsule, when I jump, is actually following the player correctly. And I saw some of the comments where we were talking about fixing this, because if you had put the capsule collider on the upper level, this rig, well, I call it the rig, the capsule wouldn't follow, which was an issue some people were having. In my case, the capsule's fine because it's following me. It's following me just fine here. But almost all of my scripts go at this level, the knight with the mesh and the rigid body and the capsule collider. So all of that's great. All that's working fine. If we look at the animations in general, so the first thing I had to tackle was just kind of looking at what's going on, like, because you want to look at your animation. And in this case, I've got two different animations. I've got the jump up and down, like if I'm not moving, and then I have the moving jump. So my jump up and down is this OH jump 1. So I'm just going to go ahead and drag my knight in here. And when you watch it, I mean, that's about what you're seeing on the screen. So he doesn't jump very high. And the same thing with the run and jump. He's not jumping really high. Now both of these, if you notice, I'm baking these into the pose, and I'm basing off of original. My Y is baked into pose based off original. So both of these are set that way. When I'm jumping up and down, I actually kept body orientation because it just seemed to look better for me. But my animations aren't the problem here. The actual problem that I found wasn't with the animations. It was the fact that I wasn't applying any upward force to this model or to this character. So let's go into the code and just kind of look at what I did to change that. So again, my whole setup is going to be a lot different. So I can't, if you're trying to use this and make your code look exactly like mine, you're going to probably not have a very good time, just simply because I have things set up totally different. But I do have a player locomotion script here. And one of the key differences that I have, one of the key differences in my system is that I don't actually check input values in any of these player child objects. I have an input handler that does that, just like in Sebastian's tutorials. He's got an input handler. But my input handler only cares about responding to input, and then it generates an event. Okay, so I use what's called the listener pattern, and that just generates the event. And then I let whatever child objects or whatever other objects want to subscribe to that, they can do that. I don't want my input handler doing anything more than this, right? I also don't want to have to be constantly writing code to monitor the input handler. So one of the things I do is, if I care about any input coming from the user, is I do get a reference to my input handler here. And then I have a reference to when he jumps. Okay. So when the jump button is pressed, the input handler is going to broadcast a message. It's going to just fire off that event. And I'm subscribing to that event here. So it's going to actually run in this input handler jump method, which I'm going to show you here in a second. So that's going to initiate the jump. Okay. I also have this thing called gravity. Gravity is just a downward a force that we apply for falling and whatnot. But I call that gravity locomotion because it's very specific to falling and very specific to the downward force. I try to keep, I make a lot of smaller objects. So in my update loop here for locomotion, one of the things that we're going to do is handle jumping. Okay, so that was commented out just to show you, because that just recreates the issue, which we saw in the beginning of the video of it. That jump is very anemic. It's not very interesting as a player. Like, I'm not going to get anywhere with that. And in some of my ideas, I actually want to do some platforming or maybe put some secret areas. So jumping, I think, is going to be a big deal. I have this state called isJumping. So just like Sebastian has a bunch of Boolean flags in the controller, I actually put those Boolean flags all in this state object. And I do that to separate the controller from the state, because I have a lot, you get a lot of flags. And I just want to pull that code out so that my controller is not becoming this massive thing. So that's all this is. And if I'm not jumping, I handle falling. So one of the deviations in this case is, if I'm jumping, if I say I'm jumping, then I don't apply gravity, which I have comment here for myself later. This does, quote unquote, defy gravity a little bit, but it looks good in the game. I actually had a fuller way of handling this problem that I didn't need. I actually only needed to go halfway. And that halfway point is simply, if I'm not jumping, handle gravity. If I'm jumping, don't apply gravity at all, but that's just part of the picture. When I click on the jump button, we're going to fire off this input handler jump, and I showed you that above. So input handler jump is responsible for initiating the jumping sequence. So if we're already interacting, I go ahead and say return out. You can't jump if you're already doing something else that the animator's working on. So we get rid of that. Next, I go ahead and I get the total movement. This is exactly like Sebastian does, other than I've wrapped that into a function because I do this so many times. So if we go ahead and just scroll down here really quick and look at this movement, if I can find the function with movement, this is nothing more than getting the vertical and horizontal movement. And I do what's called a get normalized movement. And this is everything that we've done in Sebastian's tutorials, except that in this case, I functioned them out because I don't want to have to write all this code over and over again. So anytime I find that I'm duplicating code anywhere, I function it out. That way, I'm not introducing bugs where I may change one way of doing it but forget another way, for example. So once that happens, I get the total movement, and then I have this little flag called interaction direction. This is a vector, and I set this when I'm rolling or jumping, and this just lets me know what direction I'm facing. And again, this is exactly like Sebastian does, right? So we get what direction we're facing, and then I normalize it, and then I set the Y to 0 so we don't in code move his Y-axis at all. Once that's done, I have this little method called initiate jump, and I pass how far the input moved. This says if my total movement is greater than 0, meaning they've pushed somewhere on their joystick, I want to do the one-handed run jump. So I play that animation, the one-handed run jump. This works exactly like in the tutorial. The jump is set up exactly like Sebastian did his. It'll transition to empty if they're not flying anymore, if they're not in the air, or otherwise it'll transition to falling. I get my rotation how I want, and then I apply what's called a horizontal force. Now this is key. This is the missing piece, the force. We don't have a vertical or a horizontal force right now, and we need to apply that. So this jumping horizontal force is going to be equal to, if the player was sprinting, I use their sprint speed. Otherwise, I use their normal movement speed. So right now my sprint speed is an 8 and my movement speed is a 5. And this is just the force I'm going to apply as they're moving forward. If they weren't moving at all, we're just jumping up and down. So I set this horizontal force to 0, and we're going to play the jump up and down animation. Both of those animations come from Mixamo. They are the one-handed sword and shield model. So one just jumps up and down, the other one's moving. Once we've initiated the jump, I set my state to jumping as true. And when it's finished, the animator will call this on interacting animation complete do this action on my controller. So I have to set these when I'm done. And this just basically says when you're finished, I want to go ahead and set my is jumping to false. And then I want to finish the interaction animation. So that sets all the flags. At that point, we're considered in a jumping state. Now, when we're in a jumping state, we can see our update loop is going to go do a bunch of different locomotions, and one of them is handle jumping. So if we look at handle jumping is what applies the force. So all he is going to do, he's going to say, if I'm not jumping, get out. Otherwise, if I'm jumping, I want to add 2 pairs of force. Number 1, I want to add my upward force. My upward force is going to be my transforms up, multiplied that by my strength of my player. So in my game, the stronger you are, the farther you can jump. Now, there's different ways to do this, I realize. In my game, it's strength-based. The default value is an 8. It's very similar to Dungeons & Dragons. So an 8 is your basic attribute. And right now, this will be an 8. And when you see this run, it'll be an 8. Additionally, we want to take my interaction direction, what direction they had pushed the joystick, and we want to add this force. We want to add the direction of their force multiplied by my horizontal force. And the horizontal force is right now equal to speed. So it'll either be if they run or if they sprinted. So if they're sprinting, they should jump farther, added to their strength. And that's really it. That solved my issue. So if we go ahead and I've uncommented my code, I'm going to go ahead and hopefully build this, and hopefully it doesn't crash this time. And we say that because I'm in a demo here. So, all right, cool. Everything seems to build. So we run. So by adding that update, you can see that my upward jump is a lot higher. There is that snap down to the ground that I'll probably have to figure out later. But for right now, I'm able to at least jump higher. And when I run, you can see I move a lot better. It seems to be a lot better. And if I'm sprinting and I jump a little bit farther, and I'm engaging like these little squares here. So jump, and jump off the side, boom, boom, we're done. All right. So there you have it. That is how I solved for my jump issue. I just added some force. It seemed to work great. I got to adjust some of that downward momentum. I'll deal with that later. But if you have any comments, please feel free to leave them in the discussions below. And again, subscribe and like Sebastian's content. He's doing an amazing service to the game developer community because it's actually applied theory, meaning it's a game that you actually want to see as opposed to like segments of little bits and pieces here that are really kind of hard to put together if you're not like a real comfortable with the tool. So that's all I've got for now. Take care, everybody, and I'll see you next time.